All right, so today we're starting a series of building a backdoor for Elixir Phoenix app, which is going to be, contrary to its name, hopefully useful and hopefully kind of safe Elixir web console. The naming is chosen this way that you should know what this thing is if you install it. It's basically a backdoor for your application, but it might come in handy for like developers. So the naming has been chosen intentionally. It's a backdoor, but basically it exposes web console on the internet for your application. So be careful and put it behind some authentication, etc. So what I did so far is very little. I just took in the project structure. I actually stolen it from Phoenix Live dashboard. So I copied over the files I need to from Phoenix Live dashboard, which is a really nice setup for developing those packages that you can mount into your Elixir Phoenix application and forward some requests to it. And it also has configured live view and some other things like testing infrastructure. So I just copied the project structure. It's not nice start for everything and removed everything that's related to live dashboard functionality, all of the assets and live views, etc. And instead, I just created one simple live view, which is called Backdoor Live for now, which only renders some basic layout of our to-be console application. One of the things that they also prepared in the Phoenix Live dashboard is this dev script, which, here we go, the dev exs, which is really nice and really compact way to start minimal Elixir application, Phoenix application. It configures router, endpoint, everything in the same file, and then just starts the application. So that's what I'm using here as well for development, which is very handy. You can just start mixdev and it will open this application on port 4000 like you would normally expect. So even though it's a library, you don't have to really work on top of like other application that will require this library. This is all done internally. And if you go to localhost port 4000, you can see this page and open the backdoor. And this is more or less how our, how in my views, this web console is going to look like. And a few words of explanation. On the left-hand side, we will have this sidebar that has a list of open sessions, and you will be able to start a new session and select which node you want the start session on. So intention is that this thing will, you'll be able to connect to your cluster of nodes and start session on just one node or maybe on all of those nodes and run commands, send those commands, send Elixir code to just selected nodes or all of the nodes at the same time, which I find very helpful. And then also you'll be able to shut this thing down and reconnect again, and those sessions will continue running and you'll see the output. So I find it very handy. And yeah, this is going to be the name of the session, and these are going to be like the output of the commands, and then we'll enter Elixir code here. I probably want to make this field like expandable so that you can make it bigger, and then it's going to be like syntax highlighting in it, and you can write, for example, like a module or paste a module, and it's going to be syntax highlighted and maybe give you some warnings on issues that it finds in it, etc. But that's in the future. For now, for today, we're only going to focus on functionality where you enter some basic Elixir code, hit enter, and it executes. So as you can see, currently nothing like that happens. It just doesn't do anything. And if we want it to do something, we obviously have to alter our live view. Here we go. This is, oh, that's already open somewhere. Here we go. So what we want to do is, this is the input field that doesn't have any functionality in it. I will replace it with a live view form. So in live view, we do have to assign the form to a variable, temporary variable. But otherwise, it's pretty much the same as you would have done with Phoenix form. We tell it what to do when we submit this form, and we're gonna just send a message called execute to ourselves. Add some classes. Class is gonna be flex and full width, right? Something like that. You actually close those IEX forms in this way, which is really weird, but that's how you do it. And then we need to do like text input, and it's going to be our command input, type of text. Maybe we can add some placeholder. Is going to say, I don't know, and hit enter, something like that. And we want the value to be like blank string, so whenever live view updates is going to reset, but that's okay for now. Class, and also make it full width. Maybe add some padding and remove this outline. Here we go. That's too many. Something like that. Let's have a look. Oh, it already refreshed for us, and we can write Elixir code to execute and hit enter. So a equals 1. And bang, I think it crashed. Let's have a look at the output. Yep, again, it crashed. So the whole live view crashed. Undefined function error, handle event with arity free. And we can see that we don't have this callback defined to handle, but our form already sends things to the backend. So the only thing we have to do now is to define that that callback, and it's gonna be execute. And what do we have here in the payload? We have CSRF token, which we can ignore for now. There's a command, and it has text in it. So that's how we're gonna get into the payload that user enters. Something like that, and it's gonna have text, command, and the third argument is socket, this live view socket. Here we go. And for now, let's just output it to the console. That's our command, and we return something like no reply and the socket. Here we go. That should be recompiling, and let's enter some text here. Oh, actually, maybe make it Elixir. A equals 1. Here we go. Something happened. A equals 1 has been printed out. B equals 1 has been printed out. A plus B printed out, but it doesn't do anything. It just prints it out. So let's fix that. And Elixir has this code module, which I figured is gonna be handy for us to implement what we need. And there are basically two functions we need. One is taking a string. Well, we could just do it with eval string, but we can also split it to two modules, two two steps. One just to create AST, which possibly is going to be handy for us in the future when we'll want to change it, decorate it, or whatever, and then execute it. So we can split it up in two things. One is going to be string to quoted, which given a string returns abstract syntax tree, and we will know that this is sort of valid Elixir code if this returns OK AST. So that's a good check for just the syntax. And then we're going to do code eval quoted. Here we go, this function. All right, so instead of printing out to the output, we first code string to quoted. That's our command. And it's going to return OK AST if things go correctly. Otherwise, it's going to crash for now, and that's fine. And then we're going to evaluate this code. So code eval quoted AST, and we have to provide it bindings and options. I actually don't know what the options go here yet. We'll figure it out later. I know that for the bindings, actually, let's start with no bindings, and it returns result and something for now. And for now, let's just print out the result to the standard output. Here we go. That should kind of work, I think. That compiled, okay. And that's our backdoor. So a equals 1. So what happened is that we got output 1. That's nice, okay. That's the value. Let's try something more complex, like for example, let's write some map. So it's a key and that's a value. Does it understand it? Yep, here we go. It parsed it and the AST and evaluated the code, and that was the value. We can also do things like, for example, IO inspect foo. It outputs foo and then returns the value, which is perfect. Which is not where we want the output to have, but for now that's fine. It evaluates the Elixir code. What it doesn't do is where the bindings are going to come in handy. It doesn't remember the local variables or anything basically. So if I do a equals 1, then I'm going to be like a plus the b equals 2. Yeah, that's gonna output something 1 and 2. But if I do a plus b, it's not gonna give me 3. It's gonna crash. So I'm gonna hit it, and we can see it crashed because it has undefined function a, undefined function or variable actually. So in order to fix that, we need to introduce some sort of place where we're going to store that thing. And that's precisely the binding here, which I already added here to the assigns. This is probably actually wrong for now. Okay, so we will have declare two assigns that will be persisted on our gen server, which basically it is this live view. One is going to be bindings, and it's a list of bindings, and the other one is going to be output, which we will store the output values from our commands. And in order to make this whole thing work, we need those two things. And maybe actually let's jump on to displaying this output for now, because that's also going to be handy. There's just a dummy list of 100 text messages, but if I do something like that message in, and this is going to be output, right? So we iterate over messages, that were sent to the output. And let's just inspect those. Here we go. We inspect the message. And now, after we evaluate the code, we're going to update the output with the result. So instead of printing to the console, we're going to create new output. So first we're going to take what we already have there, output, and we're going to add, well, first the command that I sent. Maybe even like add some prompt to it so that we can see clearly that this is the command. And then let's add the result to it. And then we're going to add the output of the command. So for now, it's probably okay if we just inspect the result. Yeah, something like that. And I think I get redundant inspect here, so that's probably fine if I do just that for now. Okay, so we created the output and assign it to this socket. It's going to be output. Okay, let's see how this works. So already that's empty, and a equals 1. Oh, it crashed. It crashed because there's something wrong. Erlang plus, so something here with the concatenation. Yes, obviously that's not the way you concatenate strings in Elixir. That should be way better. A equals 1, B equals 2, A plus B, and it crashes again on the same thing that we had before, because we don't remember the bindings. So our variables we declared, they're nullified on every command. So let's fix that, but by actually using the bindings. So I'm gonna use socket assigns binding. Is it binding or bindings? Bindings. Okay, binding s, and this returns the new bindings, which we are going to put on the assigns again. Here we go. Let's see what we have here. A equals 1, B equals 2, A plus B equals 3, and A, B. Cool. We can do more interesting things here now. Is just not just like calculator. You can actually execute some Elixir code, or even add Elixir code to your node. Like let's declare a module. How does one do that? Def module foo do, and just still one line, so that's really weird syntax, but I think it's gonna be like bar maybe, and let's return bar and close this. That's not very handy. We really need this multi-line thing, but oh, that crashed. One foo do def bar and nope. Why is that not working? Unexpected token. One more time. Foo do def bar do. Okay. Bar and. That's really inconvenient. But again, we declared a module and we can actually call a function on it. Foo bar. Here we go. It returns bar. Let's see whether this module has been declared like in other. We cannot. We cannot because that hasn't been started from IEX. But we can start it like that. And again, I'll declare the same module. Oh, here we go. Foo do def bar foo do def bar do bar and. Okay, we declared the module. Let's try foo bar. Here we go. So we did something very nasty, which is that we dynamically at runtime injected the Elixir module foo to the running Elixir system. So we basically have access to everything. We now have a working backdoor, which is still not a very good backdoor, but you can start and stop applications. You can get the process info, send messages. Basically, you have a working backdoor, and probably that's it for this video. In the next one, okay, so this still doesn't work great. So, for example, if I were to use logger, not sure that's even gonna work. Info foo bar. I'm gonna log it. You must require logger. Okay, so I can't even do that. But things like IO puts hello, for example, that just outputs okay for me. The same would have happened with logger, and instead it just outputs it to the standard console, and we have to fix that as well. So in next video, we are either going to focus on that, or we're going to focus on creating multiple sessions so that you can start multiple sessions and choose on which node, etc., to execute the code and unbind the executor for the code from the live view itself, so that when it crashes, it doesn't actually crash the whole live view. The thing is, I want it to remember the output, and so that even if it crashes, you'll see the error, etc., and it restarts. So we're gonna use some supervision trees, techniques, and to do that, but maybe first we're going to fix the logger and the output issue so that you can see the output on the console. We'll see. So thank you for watching and listening, and sit tight, awaiting the next video.